All right, we're going to talk about evaluating functions now. All right, I'm going to go back to some stuff that we've already talked about. We talked about function notation. We established what a function is first off, right? Then we talked about what function notation is. And it's really just this right here. Function notation is including this f of x right here. That's all that is. Instead of writing y, there's f of x. Now, why would we worry about doing all that? Because when we start talking about functions, we're talking about different characteristics of the relationship. One thing we can do once we know about a function is we can evaluate the function. All right. So, for example, by evaluating the function, remember you have function notation, f of x equals something. Let's say 2x minus 1. Okay. Remember that x is an input. So over here with the star, I'll say x equals the input. And then f of x, which is the same thing as y, equals the output. So if I put in a number for x, I will get out a number in the form of f of x. Now, how we write that? What if I wanted to know what the output is if x is equal to 1? When x is equal to 1, we say f of 1. All right, that is said f of 1. That's how you say that. Well, all that really means is instead of the x, let's just plug in a 1. So there's a 1, f of 1. Instead of x, let's plug in a 1. So I have a 2, a 1, and a minus 1. All I did was plug in x for 1 because x was equal to 1. All right, so I just used the order of operations to simplify this. 2 times 1 is 2, minus 1 is 1. So, in general, f of 1, given this function right here, is equal to 1. If I wanted to write that as an ordered pair, I could say 1, 1, because x, y, if you will, because y is the same as f of x. Let's do another one. What would, given f of x is equal to that, what would f of 3 be? Well, according to this, it's 2 times whatever x is, 3 in this case, minus 1. So I'll get 6 minus 1, or 5. If I wanted to write it as an ordered pair, my x value, which was 3, and then my y value, or f of x value, is 5. So I can get unlimited items. Let's take a look at this practice right here, the same one we've been using. Given f of x is this and g of x is that. Wait a minute, what does that mean? Well, let's go back to this. If I had two different functions, I could have one function, say f of x, and let's just call that 2x. I could have a different function based on x. It's still based on x, but it's a different relationship with x. Maybe I'll call it 3x plus 1, I don't know. When you have a different letter, f and g, that just means you have different functions. Now, you could have this function still based on an input of x. Both of them have an x as the input, right? But they are two different functions, so we call one of them f of x, one of them g of x. So on our problem here, we have an f of x function and a g of x function. F of 4 would be 3 times 4 plus 2, and simplify that. G of 2 would be, I would have to use this one, 2 squared minus 2, and simplify that. The G tells you to go with the G. The F, it would be more effective if I had a different color. The F tells you to go with the F. All right, I can simplify this. This is going to give me 12 plus 2, or 14. I can simplify this. This is going to give me 4 minus 2, or 2. Same ideas, but I have two different functions. One is f of x, and one is g of x. That is evaluating functions.